Having learned these properties, let us just try to do some small problems, right, to find maybe density or specific weight or specific gravity, right. So let us see one or two problems. So suppose we have one problem. We have to estimate the density of Krypton gas at STP given its molecular weight is 83.8 AMU. Right? So this AMU is basically atomic mass unit, right? And now it is basically defined as 1/12 of the mass of an atom of carbon 12. 1/12 the mass of an atom of carbon 12. Right? So let us try to find out the density of Krypton gas. We just saw this table where we have this values of the molecular weight and values of densities. So we can see that the molecular weight for helium is 4 and its density is given as 0.18 kg per meter cube. So as we know that in this density is proportional to molecular weight. Right? So we can write down the density of Krypton divided by density of, suppose, helium we take, is equal to molecular weight of Krypton divided by molecular weight of helium. Molecular weight of Krypton, let me write down here. You can see that the density of Krypton will be equal to molecular weight of Krypton is given as 83.8 AMU, and that of helium we just saw is 4 AMU. This will be multiplied by density of helium, which we saw it was 1.18 kg per meter cube. So this density of Krypton comes out to be 3.77 kg per meter cube. So this is how we can use these properties to determine the property of any other gases. Another small example, let us see. Suppose we need to find out the specific gravity of methane at STP. Right? So again, we can use the table which we just saw. So here we can write down the specific gravity of methane will be equal to density of methane divided by density of air at STP. So let us see what are the values of density of methane. This is 0.72 and density of air is 1.23, right? So let's use this. It is 0.72 divided by 1.23 kg per meter cube. This is also kg per meter cube. The specific gravity for methane comes out to be 0.5. So this is how we can use these information to get the properties. Now let us solve one more problem. So we know that although most modern thermometers contain alcohol, but the older one which we were using often contained mercury, right? So suppose during the fabrication of a certain thermometer, the mercury was inserted under standard conditions so that it filled the reservoir of volume of mercury in the thermometer is given as 50 millimeter cube. Now, given this is also given that a specific gravity of mercury is 13.6 and density of water is known as 1 gram per centimeter cube. So we have to calculate the weight and mass of mercury in the thermometer, right? So we are asked here to find out the weight and mass of mercury in the thermometer, and we are given the specific gravity of mercury as 13.6 and the density of water is 1 gram per centimeter cube, and also the volume of mercury in the thermometer reservoir as 50 millimeter cube. So this problem can be solved by noting that the weight of a volume of fluid is basically W, which is equal to rho G into V, while the mass of the same volume is equal to rho into V. Now we are given the specific gravity of mercury, so we can calculate the density of mercury by using the formula. Specific gravity of mercury will be equal to the density of mercury divided by density of water, right? So density of mercury will be equal to specific gravity, that means 13.6 into 1 gram per centimeter cube. So density of mercury will come out to be 13.6 gram per centimeter cube, right? So now the weight can be calculated as density of the mercury, right? I'll write down mercury here, and this is the volume of mercury, weight of mercury and mass of mercury. So weight of mercury can be found out by density of the mercury, that is 13.6 into, and just converting the units into G, that is 9.81 meter per second square multiplied by 50 millimeter cube multiplied by 1 centimeter divided by 10 millimeter per cube. So this is just I have taken care of the unit conversion. So ultimately this will come out to be 6.67 into 10 raised power minus 3 kg meter per second square, right? This will be simply 6.67 into 10 raised power minus 3 meter. So this will be the weight of mercury, right? Similarly, we can calculate the mass of mercury, right? So the mass of mercury will will be just density of mercury into volume of mercury. So the density of mercury, we just have this into 50 millimeter cube. This will be converted as this, right? Here also it will be this. So this will be giving you the mass of mercury as 0.680 grams, right? So this is how you can solve these types of simple problems related to properties of fluid, like mass density, weight density, specific gravity, specific volume, right? So just notice the use of unit conversion factors, right? So I hope you people have studied this conversion and you people know how to convert the units. So I'm not elaborating it further, but I hope you will understand the way I have written down. So just go through these problems, try to solve these and few more from the books of similar kind, so that you are pretty conversant with the unit conversion and all, and the formulas or basic formulas of these properties of fluid. So this is about the basic properties of the fluid. So we discussed a bit more on mass density today, about the solar pond. Then we discussed the properties of specific volume and specific gravity, and why this specific gravity is important and why it is used widely. And we also solved 2-3 problems related to these properties. So I hope you have understood the basic properties. Next we will see the other properties like viscosity and all. So this is all for today. Thank you very much.